Today, I'm gonna start with chapter 3, Fundamental Hydrostatic. I will cover a very interesting topic, and we can expect one problem in the first exam from this topic. Just a reminder, last meeting, I started with a few concepts about hydraulics, one of them called unit weight, which called gamma equal weight divide volume. That means if you are looking for weight of any body, any fluid, any liquid, anything equal gamma time volume. If you know the unit weight or specific weight, sometimes called specific weight, and multiply it by volume, you can get the weight. And also, we learned last time something about specific gravity. SG equal gamma any material gamma of any material divide gamma water. Do you remember? Gamma water equal 9,810 Newton per cubic meter, or 62.4 pound per cubic feet. Okay, just a reminder, specific weight equal weight divide volume. So today we will start with something called vertical hydrostatic pressure. If you are looking for pressure from any liquid, the vertical pressure equal gamma H. Gamma, specific weight of this liquid, or equal rho GH. Last meeting, I covered another term called rho, which is called density. And the gamma equal rho times G. So gamma H is equivalent to rho GH. Do you remember that? G is the acceleration of gravity, equal 9.81 meter per second square, or 32.2 feet per second square. So any pressure for any liquid equal gamma H or rho GH. I highly recommend you use this term, gamma H. If you would like to get a weight for any liquid or any material equal gamma V, V is the volume, time gamma, you can get the weight of this liquid. So the term hydrostatics refers to the study of water at rest. Hydrostatics means studying water at rest without movement. So today I'm gonna talk about something called water pressure. Water pressure, P equal gamma H. Gamma is the specific weight of water. H is the height between the point and the water surface. We are done with today the meeting. Once we learn how to use this equation, P equal gamma H. Gamma is the specific weight of water. H is the height from the point to the water surface. So the pressure field in a static liquid equal gamma H. This pressure is equal in all directions. This pressure is perpendicular to the surface. The resultant Fr at the centroid of the triangle. I'm so sorry. What you mean by triangle? Okay. If you have a container, this container has liquid, water, and we have 2 points. Point at this location, point number 1, and another point at this location, point number 2. Pressure at any point equal gamma H. We are looking for pressure at point 1, and what is the pressure at point 2? I have a question. Anybody can tell me what is the value of pressure at point 1? What is the value of P1? What do you think? What is the value of P1? Any answer? Any answer, guys? What is the pressure at point 1?
Is it like gravity? Or no?
Okay, thank you, Melvin.
0.
Yeah, that's right. Guys, can you apply this equation to get the pressure at point 1? Okay, gamma of water time H of water. We have a value for gamma. This value probably 9,810 Newton per cubic meter or 62.4 pound per cubic feet based on what is the units you are using. So we have a value for gamma. Can you tell me what is the value of H? H is the height or the distance between the point you are looking for and the water surface. Okay, what is the height between point number 1 and the water surface? Do you have height between this point and the water surface? No, we don't have height because the point 1 at the same location of the water surface. So H water is 0. We have a value for gamma water, that's fine. If you multiply gamma water by 0, your pressure will be 0. We don't have value for pressure at point number 1. For pressure at point number 2, we have a value for gamma water, that's right. Do you have height, distance, vertical distance between point number 2 and the water surface? Yes, we have. We have height here, H. So we have H. If you multiply this one by this one, you will get a value. So we have a value here. This value of pressure at point 2 is perpendicular to this surface. If you connect between point number 1 and point number 2 the values of pressure, you can get a triangle. So your pressure looks like a triangle. The pressure looks like a triangle. How can I get this triangle? One more time. One more time. This point is very important. Please pay attention. We have water surface like this. This height equal 10 feet. And what is the pressure at point number 1? What is the pressure at point number 2? P1 equal gamma water H1. The value for gamma water, because this one in feet, it will be 62.4. What is the height between point number 1 and the water surface? Do you have height? No, we don't have height. Your pressure will be 0. So your value here is 0. Pressure at point number 2, gamma water times H2. Gamma water is 62.4. What is the height between point number 2 and the water surface? Do you have height in between? Yes, we have 10. Your pressure will be 624 pound per square feet. This value will be perpendicular to this surface. So we have a 0 value. At 1, we have a value here, 624 at 2. If you connect between the two values, we can construct a triangle. This triangle can be called water pressure on this surface. So this shape is derived from this equation, gamma H. This is called pressure. If you would like to convert it to a force, get the area of this triangle. So this force will be area of the pressure shape. So this force will be 1/2 times 624 times 10. Guys, do you remember what was the area of a triangle? This value 624, this height is 10. So the equivalent force is the area of this triangle. It will be 1/2 times 624 times 10. 1/2 times base times height. I can get the area of this triangle. This area equal the force which is equivalent to the water pressure. One more time. This pressure or this force is perpendicular to the surface. The area of this triangle, which is 1/2 times base times h, I can get the equivalent force for this pressure. Guys, pressure which equal gamma h, this h is the distance between the vertical distance between the point and the water surface. In this case, here is h. In this case, here is h. In this case, here is h. Whatever, I don't care about the shape of the container. The vertical distance between the point and the water surface is called h. The vertical distance between the point and the water surface is h. The vertical distance between the point and the water surface is h. This is the meaning of h. So be careful. H is the vertical distance. Vertical distance between the point and the water surface. If you don't have distance, your pressure will be 0 because H is 0, so gamma times 0 will be 0. Okay, I have another comment or another case, but any question so far? Any question so far? Okay. If we have the water surface is here, water surface, and the wall is here. We have a wall like this. And we have 2 points, point number 1 and point number 2. Point number 1 at distance 5 feet from the water surface. Point number 2 at vertical distance from the water surface by 10 feet. What is the value of P1? Pressure at point 1. What is the value of P2? Okay, we know pressure equal gamma H. Pressure equal gamma H. Because your units are US unit, so gamma equal 62.4. What is the vertical distance? What is the vertical distance between point number 1 and the water surface? Do you have a distance? Do you have a distance between this point and the water surface? Yes, we have 5. If you multiply 62.4 times 5, your pressure will be 312. So we have a value here, 312. This value perpendicular to this surface. Point number 2, gamma H, gamma 62.4. What is the value of H? H is the vertical distance. Vertical distance must be vertical. Vertical distance between point number 2 and the water surface. How much? 10. Your pressure will be 624. So we have a value here. 624. This value is perpendicular to the surface. If you connect between this shape and this shape, you can draw something looks like trapezoid. Like this. So this is the shape of pressure distribution. If you would like to get the equivalent to force for this pressure, you can get the area of this trapezoid. That makes sense? So sometimes we have something called submerged surface or submerged plane, like this one. So we have 2 points. The first point here, we will have pressure. The second point will be here. We have another value of pressure. If you connect between this value and this value, you can get a shape looks like trapezoid. If you would like to get the equivalent force F, you have to get the area of this trapezoid. Any question? If you have any question, let me know.
So on that example, would we split up And solve for the area of a rectangle and then a triangle.
Yes, if you want, if you can get the total area for this trapezoid one time, that's fine. If you don't, I highly recommend to divide it to two areas. The first one is a rectangle with this equivalent force. The second one will be triangle with another area and another equivalent force. Make sure for rectangle, the location of this force at the centroid of the rectangle. For triangle, the location of this force will be at the centroid of this rectangle, triangle. For rectangle, at h divide 2. For triangle, at h divide 3. Just for your information, for any rectangle, the centroid at mid-height. For any right angle triangle, the centroid at 1/3 of the height. Just for your information. One more thing. If we have water surface and we have inclined surface like this, how can we draw the water pressure distribution? The vertical height here is 5 feet. The vertical height here is 10 feet for this point and this point. What is the difference between this case and this case? Do you think we have a difference? Okay, point number 1, point number 2. So P1 equal gamma water times H1. Gamma water 62.4. H1, the height for point number 1 to the surface, the water surface is 5. If you multiply 62.4 times 5, your value will be 312. How can I draw the 312? How can I locate this value, 312 pound per square feet? How can I put this value? We have information here which is very important. The water pressure is perpendicular to the surface. The water pressure is perpendicular to the surface. So that means if you would like to locate or to put the value 312, you have to locate it perpendicular to this surface. 312. Perpendicular. The first case, we put this value perpendicular to the surface. The surface is vertical, so your value is horizontal. At this time, the surface is inclined, your value will be perpendicular. Pressure number 2, gamma water times H2, so 62.4 times 10 equals 624. Your value will be perpendicular to this surface, 624. If you connect between the two values, your pressure looks like this trapezoid, but this trapezoid is perpendicular to this surface. Also, you can convert it or you divide it to rectangle with equivalent force and triangle with another equivalent force. So I can convert this pressure to two forces, F1, which is the area of this rectangle, and F2, which is the area of this triangle. I will do example number 2. Example number 2. I skipped a few slides. I will go back to them next meeting. But for today, I will start with example number 2. We have a vertical trapezoidal gate. This gate looks like trapezoidal shape with its upper edge located below the free surface of water is shown in the figure. 2 meter, 5 meter. Draw the water pressure distribution on the submerged gate. Okay, what is the pressure at this location, P1? What is the pressure at this location, P2? What is the pressure at the top? What is the pressure at the bottom of this gate? It's very simple. Your pressure equal gamma H. Gamma water in this case, because you are talking about meter, so your gamma water would be 9,810 pound per cubic meter. So what is the pressure P1? Gamma time H. What is the H value for point number 1? What is the vertical distance between this location and the water surface? Do you have a distance? Do you have a vertical distance? Yes, 5. So the pressure value $49,050 pound per square meter or per meter square. What is the value of P2? Gamma water time H. What is the vertical distance between this location and the water surface? Do you have a vertical distance? Yes, 7 meter. So 9,810 times 7. This value will be 68,670 pound per square meter. If you would like to draw this distribution, okay, go ahead and put this value. How much? 49,050. And this value, how much? 68,607. And to connect between both of them by a line. So your distribution of pressure will be looks like trapezoid. We need only to draw the water pressure distribution. That's it. We are done with this example. Another example. We have a vertical surface. Vertical surface like this. With height, this height, 2.5 feet. And width equal 2 feet. That's fine. It's submerged 1 feet or below the water surface. Here is the water surface. This submerged distance is 1 feet. Find the value of the resultant hydrostatic force. Let's do first what is the pressure distribution. Point number 1 at the top, point number 2 at the bottom. So pressure equal gamma H. P1 equal, I'm gonna use feet. So gamma water is 62.4. So guys, be careful about this point. Gamma water, sometimes we use it 9,810. If you are talking about SI unit, which is meter, which is Newton, because 9,810 Newton per cubic meter. if your numbers or your problem in US unit, I'm gonna use 62.4 pound per cubic feet. If you are talking about US unit. Okay, so be careful about this point. Anyway, 62.4 times H. What is the vertical distance between point number 1 and the water surface? We have 1 meter. So your pressure will be 62.4 pound per square feet. This value is perpendicular. 62.4. Pressure number 2. Gamma 62.4. What is the vertical distance between point number 2 and the water surface? What is the vertical distance? 3.5 feet. So this pressure will be 218.4. 218.4. Then I will connect between the two values. I can get this distribution as a trapezoid. If you would like to find the value of the resultant hydrostatic force, that's fine. I can divide it to rectangle with F1 and triangle with F2. This rectangle and this triangle. What is the value of F1? 62.4 times 2.5. This area of rectangle is 62.4 times 2.5 times something. F2 is the area of this triangle. What is the area of this triangle? This little value will be 156 equal 218.4 minus 62.4. Anyway, so 1/2 times 156 times 2.5 times something. I can get this value and this value. Anybody can tell me what should I use here? (62.4 times 2.4 is the area of the water pressure. 1/2 times 156 times 2.5 is the area of the water pressure. What you need to multiply here? No? No? Let me explain it here. If you have a wall like this, and this wall has a width, your pressure distribution that you draw is here. We have a value here, we have another value here, and you draw this trapezoid. This pressure only at this edge, and you converted this pressure to F1 and another F2. This F1 and F2 coming from this pressure and this pressure only on this edge. Do you think the water pressure is only at this edge or is continue to pressure the width of the wall or the gate? I believe this pressure is extended through the width of the wall. So if you have a width for this wall, you have to multiply your values by this width. So 2 and 2 are the width of the gate. The width of the gate. One more example. We have a plane surface with length 4 feet and width 3 feet is inclined 30 degrees with the horizontal and submerged 1 feet below the surface, the free surface of a container of water. So we have this plate or this surface inclined with length, first with length 4 feet with 30 degrees with the horizontal. This angle is 30 degrees. We have a water surface. So we have this submerged distance 1 feet. We are looking to find the resultant hydrostatic force, not pressure. We need to convert the pressure to force. Okay, first of all, we will have 2 points. One at the top, one at the bottom. Pressure equal gamma H. P1 equal gamma H. 62.4 times H 1 meter, your value will be 62.4. P2 equal gamma H, gamma 62.4. What is the value of H? What? Remember, H is a vertical distance between the point and the water surface. What is the vertical distance here? Any answer? So can you get this vertical distance? Yes, I can. Sine 30 in this right angle triangle. Sine 30 is the opposite. I don't know why. Divide hypotenuse, which is 4. This one is known, this one is known. I can figure out the vertical distance y. This vertical distance will be 2 meters. Oh, I'm sorry, 2 feet. So that this one is 2 feet. So the vertical distance H2 equal 3 feet. 62.4 times 3, it will be 187.2. So we have a value here. We have another value here. So we have this trapezoid. $62.4 and 187.2. I can divide this shape to rectangle with F1 and triangle with F2. The value of F1 equal 62.4 times the length of this gate 4 times the width of this gate 3. $748.8. F2 will be the area of this triangle. 1/2 times 4 times 724.8 times the width of the gate 3, 748.8. So the resultant hydrostatic force is F1 plus F2, so the total force FR equal F1 plus F2. I can get the final answer. So keep in your mind, the pressure is perpendicular to the surface. So if you have inclined surface, your pressure will be perpendicular. If you have trapezoid, it should be divided to two shapes, rectangular shape and triangle shape. Then you can add F1 plus F2 to get the resultant force. Any question? Guys, do you have any question? Okay, I will stop here. Next time, I will go through example number 5, and then what will happen if you have a curved surface. What is the difference? But let me stop here at example number 4 and see you on Thursday.
Wait, I think I have a question.
Yeah, go ahead.
What, and in the very first example you did, the one that you created, not the one that was on the notes, but can you go back to that, the very first example?
Which example?
The first one that you gave us separately. Go back. I'll tell you when.
I'm sorry. Which example?
The very first one that you made, but the one that you wrote, not the ones that are on the notes, but the one that you wrote, and your other. Yeah.
The first one?
Yes. I think there was a mistake there.
This one?
Actually, and it'll be like the next one. Go down. That one. Okay, so in P2, wouldn't it be 15 instead of 10 on the distance?
But 10 is given as the distance between this point and the water surface. 10 is given as the total height.
Oh, okay, yeah, I mixed.
Not the height of the gate. Okay.
Yeah, I see.
So
right.
be careful about this point.
Okay. Yeah, I see why. I'm sorry. All right.
That's fine. In this problem, in this one, 2.5 is the height only until this point. So I have to add 2.5 plus 1 to get the total height.
All right. Thank you.
So make sure what is the difference. Okay.